So in this section, we introduce another hypothesis test. We are looking to test to see if there is a relationship between the two variables. And so we ended Unit 4, or our last part of the statistics course, with these hypothesis or significance tests to see if we had statistical evidence that something was happening, that we're observing some relationship. And so thinking about what we did previously, we calculated the least squares regression line right here. And we used that as our relationship, right, to describe the relationship between two quantitative variables. Important in this equation was the slope, right, and the y-intercept. Each of those had some significant meaning, right? They meant something in the context of the situation. And what we learned was that we analyzed the correlation coefficient, right, and gave you a kind of a sense of if it's close to 1, then we have an association. If it's 0, we have no association. And so what you want to recall within the context of the regression equation is that if the slope is 0, that means we have no association. Think about that would be like the data points are all scattered randomly around, which you've seen before. And then our R value is equal to 0 or close to 0. And so in this hypothesis test, what we're doing is we're going to be testing the slope. What is the value of the slope, right? And so in order to run the test, we have the data for the two quantitative variables. We will then have to go through some steps that we've done before, right? Have evidence that that it fits a line, that our data is linear, right? The conditions and assumptions for this, and we can use StatCrunch or ArtistStat to help us with this portion also. Here are some instructions for the ArtistStat. I'm sorry, for StatCrunch, the ArtistStat. I have it on the notes. I'm having this set of notes, but you'll have those on the sheets on how to look for a fitted line plot. And then what we need to do is then test what we want to analyze are the residuals. Remember, the residuals are those values of how far, right, our observation is from the prediction, right? So we make these predictions using the least squares regression equation, and then we determine if how far they are. And so to run a hypothesis test for a slope for the least squares regression, does it equal 0 or not, is our test, okay? We have to make sure we have that linear relationship. We want to make sure, again, we have independence, right? There's no relation between the observations, so they're independently sampled. Another one is the residuals are assumed to be independent, right, based on a time or some other factor, which again is a little more technical, but we'll look at that in some of those problems. And that the residuals, the distribution, the histogram of residuals are normally distributed, meaning that there's no pattern within how, or they're not kind of skewed in some direction of how far off our observations are from the predicted, right? They're normally distributed. And then we want to also know that within that context that all of the residuals, and this is a cool term, homoscedasticity, right? That we have equal variances in the residuals. Kind of not only are they normal, but then they're kind of equally spread out. And then you'll get a residual plot when we look at the residuals to see how they actually are related. They'll be kind of scattered around. And of course, we want to make sure that the data are produced from a random sample or some randomized experiment. And again, this is what allows us to go ahead and run a hypothesis test.